Hello everyone, welcome to Nrcm. This is Shravani and I'm going to explain operating system of Unit 3 and methods for handling the deadlocks. So now we'll be saying like what are the different kinds of methods for handling the deadlocks. So there are two methods, one is deadlock prevention method and second one is deadlock avoidance methods. So here this allows the system to enter the deadlock state and then recovers. Normally, what is the meaning of deadlock prevention? So what are the steps we need to take in order to prevent the deadlock occurring? I'll be explaining. And next, deadlock avoidance. In case if the deadlock occurs, if in case if occurs, how to avoid the deadlock, or in case if the processor requesting for the resources, before requesting for the resources, what all things we need to take care. If the process is requesting the resources, then only I think we can avoid the, if the some resources are allocated or not, based on the resources only the deadlock will be occurred, right? So here, so how to avoid the deadlock will be taken care. Now we'll be going to the next slide, that is deadlock prevention. First we'll see how to prevent the deadlock. So there are like four types. So first one is mutual exclusion. So mutual exclusion is like, if the resources, when the deadlock occurs, if the process is holding the one resource and it is waiting for other resource, then the other resource is held by the different process. So then only what happens, this kind of deadlock occurs. So this mutual exclusion will tell is telling that suppose the resources are not shareable, or if any there is, based on the resources should be shared to the process, then only, based on the resource, if there is a shortage of the resource and that resource should not be allocated to the process, or else if any deadlock is occurring, then we should end that. Operating system should take care like that resource should not be allocated to that process. So if you take care of this, then this deadlock can be prevented. So it can be prevented. So the name is called, the name is like mutual exclusion. Mutual exclusion refers like we should create such an environment. We should create such an environment where the processes shouldn't like request for the resources which are already held by the other processes, or else if any of the process is requesting for that resource, so the operating system should take care that should not form a cycle and the deadlock shouldn't occur. This is mutual exclusion. Next, coming to the hold and wait. So in general, hold and wait is like I'm holding one thing and I'm waiting for other thing to happen. Okay, like I'll not release whatever I'm holding until I get what I'm waiting for. So in general, so this is only explained in this hold and wait. Like here, suppose if there are two processes, this is process 1 and process 2, and this is resource 1, and there are two resources, and this is resource 2. So what happens, this process 1 is holding, means it is having this resource, it is in its hand, means resource 1 is in its hand, and this is requesting for resource 2, and this resource 2 is not empty, and this resource 2 is held by the other process, that is process 2. And the same happening with the like process 2. So this process 2 is holding R2, and then it is requesting for the R1. So this is called as hold and wait. See, these red color marks are the processes are having these resources. I think now it is clear. See this, see resource 1 is held by process 1 and resource 2 is held by process 2. Okay, and it is a resource, here process 1 is holding the resource 1 and it is requesting for, see this yellow line, it is requesting for resource 2. and the same like the process P2 is holding for R2 and it is requesting for R1. So what this I mean what this will do, what this process 1 will do, so it won't release this R1, it won't release this R1 until it gets this R2. Okay, and what this process 2 will do, process 2, it won't release this R2 until it gets R1. So this is called as hold and wait. So each process is holding one process and they're waiting for another process. So at this condition what happens, the deadlock will occur and this will enter into the infinite loop. So and here the deadlock will occur. This is about hold and wait, and as it is like it must guarantee, means this hold and wait situation shouldn't occur. So if you want to prevent the deadlock, it shouldn't occur. So here we must guarantee that whenever the process requests a resource, it does not hold any other resource. Okay, see here, if one is it is requesting for R2 and it should not hold the any other resource. Okay, and required process to request and be allocated as its resource before it begins execution, or allow process to request resources only when the process has none allocated to it. So means like if any of the processes are free, then only any of the resources are free, then only the process should request for that resource. And if in case low resource utilization, whenever the low resource utilization is there, then starvation will be possible. Starvation is possible. Like low resources are like, so if there are starvation is like only like there is a lack of resource. Suppose for example there is only R1 and R2 are there. So R1 is allocated to R1 and R2 is allocated to R2, P2. So suppose consider there is one more P3 process is there. So it is waiting for R1 or R2 to release. So the communication here, the communication is not ending here. So R1 is still communicating with P1 and R2 is still communicating with P2. So here this process is suffering from the starvation. This is called as starvation. Okay, and next coming to the coming point is like no preemption. No preemption means like if a process that is holding some resource, if it requests to another resource that cannot be immediately allocated to it, then all the resources currently being held are released, and preempted resource are added to the list of resources for which the process is waiting. And here process will be restarted only when it can regain its old resources as well as the new ones that it is requesting. So here no preemption shouldn't occur. No preemption shouldn't occur means suppose if any of the processes is like if any of the suppose if process P1 is executing or it is utilizing the CPU, in the middle of the way if process P2 comes with the highest priority, then process P1 should be, so it should be paused, it should be preempted, and the resources which are added to that process also should be in waiting stage. And once when the old process will be resumed, then it can regain its old resources as well as any of the if as well as, and if that process is, if it is requesting for any of the new resources, that new resources should be gained by that process, or that new resources should be allocated by that process. So then only this no preemption method can, if we use this no preemption method in this way, so we can prevent the deadlock. And next is circular wait. Circular wait is like, as we discussed in the previous slide, like the circular wait is like all the, if there are P0 to Pn, P0 to Pn process, P0 is holding it is forming the circle. Like see if here P1 is there, next P2 is there, next P3 is there. Okay, here what happens, and next P4 is there, so go on up to n. So if P1 is holding one request, it is holding one resource and it is waiting for P2. And P2 what happens, it is holding one resource and it is waiting for P3. P3 what happens, it is having its resource and it is waiting for P4. And P4 what it is doing, it is having its resource and it is waiting for P1. Okay, this is called as circular wait. So this kind of circular wait or cycle shouldn't form. So then the deadlock, we can prevent the deadlock. Means what happens if this circular wait shouldn't form, what we have to do, So whenever the process requests the resource, the resources should be provided. It must be try to provide it to the process. And this is all about the deadlock prevention. Thank you, and I'll be continuing with the next video.